Okay, here we go. First of all, data. Data is all around us every day. When you're looking through the newspaper, they're often telling you data, like how many people were attacked last year in Minneapolis, or sometimes there's good data, like how many kids we had that were National Merit Scholars last year. There's some schools that have only had like one National Merit Scholar in their history as a high school, and we had like 32 last year. Pretty amazing. So anyway, we have a five-number summary here. This is basically just this is not to say that our data has five numbers in it. It means we can summarize the data with five major numbers, and these can be used to make a box and whisker plot and all kinds of other things. Okay, to start with, if you were going to do something with this data, you'd probably want to line it up from smallest to biggest. That'll help you find the middle one, the median. So would you first of all, on your paper, rewrite these numbers except from smallest to biggest? Yes, 23 is the smallest. Don't say them all from there. Just write them in order from smallest to biggest. Don't get distracted. So 23 should be first. And then do I have to write the 24 like multiple times? Yep. 4 to 4 to 4. Then what? 26. 29. 31 and? 31. Not. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. Now that I got them lined up, it does make it a lot easier to answer some of these. The minimum, that's an easy one. What is it? 23. And then the maximum, that's down here, is number 5. I like to do that next. 31. And then the first quartile, that's kind of weird. Quartile, that means if you were going to divide up your data into quarters, you would say this half of the data is your lower half of the data, right? And that's your upper half. So what's exactly between those two is something. What's it called? A median. And the median here is right between 24 and 26, what would be right between there? 25. All right, so that goes under median. The first quartile and the third quartile are these numbers, like right in the middle of that set or right in the middle of that set. Okay, the first quartile is this one. Okay, that's the lower numbers. All right, so what's exactly between 24 and 24? 24. And the third quartile is right between 29 and 31, which is what? 30. And then the last thing is the IQR. Do you remember what that is? Interquartile range. Very good. The interquartile range. Well, that's saying range means like the biggest to the smallest, and you subtract. So the range of this whole thing would be 23 to 31, and you subtract. I mean, you can say it's 8. Okay, but the range between the quartiles is like from here to here, and the range, the difference between those two is 6. All right, now, could your calculator do all of these things if it was programmed right? Yes, it could, and it is programmed right. Let me show you how you do it. So grab your calculator, go under Stats, the Stat button. Okay, I've got the calculator up. You can't see the keyboard at home, but you'll be able to see the results as they go in. I'm going to be putting this under, actually I should slide it over just for a second first so that you can see which button you press. It's this one that's going to turn red here, the Stat button. And underneath Stat, you want to edit your list. Now, is there anybody out there whose lists, like L1, L2, L3, aren't there? Like yours have been renamed or one of them's missing. You got that? Anybody? Where's the Stat button? It's 2 spots to the right of the green button. Okay, good. So under Stats, we want to go under L1, and we want to enter all those pieces of data that we had in the first place. They do not have to go in from smallest to biggest. So I'm going to just type them in from the original. 26, 24, 24, 29, 26, 24, 24, 29, and then 31, 31, 23, and then 24. Okay, now that I got all my numbers in there, here's what I can do to try to get my 5 numbers. I go under Stat again, and then I go under Calculate. I arrow over to the Calculate menu, and then one variable stats, and I hit Enter. Now it wants one var stats, but it wants to know of which list. See, you can have like 25 lists in here at the same time. So which list did we just do that on? L1. So how do I type in an L1? There is a spot for it, but the best place to know is under list. It's right above stat. You see right above stat, you see the word list? So I go second list, and it tells me all the different lists, and I pick the first one. There. Yes, you can do it a different way. Okay, but I'm just trying to show you where the lists are located, because some of them are weird. They're not on the keyboard. Anyway, did you get the L1 up there?
Yes, sir.
All right. Then I hit Enter. Now, this is everything you'd ever want to know about that set of data. All right, there's that first one, the X with the little bar over it, and do you have any idea what that means? That's the average. Okay, so it's averaging them. Do you know what that little squiggly E looks like? Or you know what, it looks like a squiggly E, but do you know what it is? It's a sigma, which means like add them all up. Yep. And they added them all up in, and it's 212. Okay. The next thing is adding them all up except it's squared. That's not 212 squared. It's you take each number and you square it and then you add them all up. You do that for kind of some more advanced stats stuff. The next thing is this S sub x, and the next one is sigma sub x. And those are the standard deviation. Now let me try to make sure you understand what that means. We're going to use the one that says S because this sort of sounds like standard deviation. All right, and what it really means is standard deviation of a sample. That's why it's an S. The sample is like where you just take a poll. Like when they ask, who do you think is going to get elected this coming November, and they do a poll, do they ask everybody in the United States? No, they just ask a sample. And so when you're doing samples, that's when you use the S one there. All right, so it's 3.33. The standard deviation means how far a normal number from this list deviates from normal. What do they consider normal then? The average. Okay, so if our average of these was 25, do you remember what it was in the calculator? 26.5? If 26.5 was the average, I'm going to call it X with a bar over it. If our average was 26.5, do you get that this one is a little ways away from the average? It's not exactly equal to the average. Do you get that 29 is actually a fair ways away from the average? 31 is the longest one that's, it's the farthest away from the average. All right, so if we took the average person's height in here, okay, and we found somebody who is way taller than everybody else, they would be deviating a lot from the average. Let's say that this was a room full of people that were all about the same height. Kind of weird. They were like all about the same height. Then their standard deviation would be very low because the standard or the normal amount of deviating from normal is not much. So if there was a room that had a huge difference, you had really tall people and really short people, then their data would probably have a big standard deviation. Do you get what standard deviation is then? It's how much it deviates from the norm. Yes?
So it's standard deviation.
That's the S one.
The average.
It's kind of like the average amount away from the average, except there's one more thing in there. They square it. You remember seeing that thing where it was squared? They square it, and then they take the square root of the whole thing. It's kind of crazy, but it's a long process. I'm not trying to tell you all about how to figure it out by hand. You can actually do that, and I'm pretty sure they do that in some of the higher level math classes. They actually make you compute it by hand. But for right now, I just want you to get what a standard deviation is. All right, so let me give you some examples of stuff, and you tell me whether it would have a high standard deviation or a low. You go into a, let's see, you go into, okay, you go into Apple Computer, and you pick out 10 random people. Would their height be likely to be all about the same? No. So then would it have a high standard deviation or a low? Right. All right. You go in and you weigh a bunch of top supermodels. You find their weight. Okay, would it have a high standard deviation or not? No, it would be pretty low. All right. You take you find the 10 best scoring people on the last math test and you find their weight. Do you think it would have a high standard deviation or a low? High, because there's probably no correlation between like how much you weigh and whether you did well in the last math test. Do you know what I'm saying? It's like the average of the average differences. I'm not saying it right. I'm just trying to give you a way to think about what standard deviation means. And so if everybody's about the same as each other, if all the data is about the same as itself, then there won't be much deviation from the norm. So the standard deviation won't be much. Okay. So moving on. What else can I get off that 5-number summary? If you arrow down, there's more. Do you see the n equals 8 there? What does that mean? Yes, 8 is ocho in Spanish. Other than that, what does 8 mean? It's the number of numbers in our data set. We had 8 numbers in there. That's what we typed in. That's what n is. It's how many numbers do we have? Okay, moving down. Min. Ooh, I know that one. What's it stand for? Minimum. How about Q1? Quartile 1. We figured out it was 24, and the computer agrees with us. How about med? What do you think that stands for? The median is 25. Look at this. It figures out all this stuff for us. Q3 is 30. That's the third quartile. And then the maximum, and that's the biggest number of them all. And that's it. All right. So if I had to make a box and whisker plot, I would need all of these numbers. Minimum, maximum, Q1, Q3, and the median. And I don't know if you've done this in a while. So I'm going to just ask you, do you think you'd be like, if I gave you 8 numbers, do you think you could make a box plot for it like super easy or not? Okay, give me a scale of 1 to 5. Like 5, it's super easy. 1, it'd be really hard. All right. So I have a high standard deviation in here. I got some 1s and I got some 5s. So some people would totally remember it, some people don't. All right, so if we were going to make a box plot, here's what it looks like, or a box and whisker it's sometimes called. You have a big number line, and then it kind of looks like that. Remember those? All right. So if I actually had to make it for our 8 numbers, these spots here, 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 and here, those are the big 5 numbers that you need. What do you think that one is? The minimum. That one? Maximum. What's that one? Quartile 1. What's that one? And that one? The median, actually. The median, the middle. This is all about finding the middle of the data, and then you find the middle of the low end, and then you find the middle of the high end. Now notice that if this was like all about being perfectly symmetrical, our box plot would look more symmetrical, where everything was exactly in the middle of things, and this distance was the same as this distance and all that, but they're not. So when you're all done with your box plot, sometimes it looks like it's all scrunched to one end. Like if I had a box plot that kind of looked like this, maybe you remember this, maybe you don't. How much of your data goes right in there? Half of it. The lower half of your data is all pretty close to each other. The upper half of your data. You get that? How about the lower 1/4 of your data? There's the lowest 1/4 of your data. So what I'm trying to say here is 25% of your data is in here. 25% of your data is in here. 25% of your data is in here. And the last 25% of your data is in here. Same amount of data. It's just some of it's really condensed, like your data was all a whole bunch of numbers repeating over and over again. That's when they're really small like this. Whereas this had a big range. It's the top 25% of my data, but there's a big difference between them. There could be one big outlier that's making it stretch way to the end here. Okay. So now if I actually had you make one, I would use my calculator. I would find my 5-number summary on the calculator, and then I would just have to make a number line that included from the smallest to the biggest of those numbers. All right, and then we could do it. So let's make a box plot for the one you have on your calculator right now. So I would need to know what's the smallest number I need on my number line. And I would probably number a little bit lower than that, like 20, 21, 22, 23, because I'll eventually, that'll show me a little bit of like breathing room on the end of the graph. It just looks better. 24, 25, 26, 27, 28, 29, 30, 31, and again, some breathing room. 32, 33, 34. I'm kind of out of board there, so I'll stop. Okay, so now, if I'm going to do this, I start with my lowest number. I draw a straight line all the way through to my highest number to make a box plot. All right. Then I got to find my lowest quartile, my first quartile, and my third quartile, because they're my edges of my box. Can you remind me what was the quartile 1? 24. So I'm going to put the edge of my box right there at 24, and my box is going to extend off this way until it gets to, what's the quartile 3? So I got to go all the way up to 30. And then the last thing I would do is put in my median of the whole data set. What was the median of the whole thing? So this data has kind of got a really fat box, and the whiskers aren't stretched out very much. So if I said I was going to take this group of people to get some extra help because they were my lowest quartile, my bottom 25%, my top group would be this group. They'd be my top 25% of my class. Okay, which group has the biggest spread in it? If this was like scores on a test. Yep, from here to here. My people that are not my top people, but the near the top, they had the biggest spread in the data. Okay, they were the farthest apart. All right, and these guys are also pretty close together right in here. All right, so that's how to make a box plot. Now, your homework for today has box plots. It doesn't have much on standard deviation yet. We're going to talk more about that tomorrow. But it's got a lot about making a box plot, reading it, and you can use your calculator to make them, which is really, really handy. So I think I've showed you enough about how to make the 5-number summary. And tomorrow I'm going to show you how to do something really cool with those lists. And it makes it your calculator just like a spreadsheet is on a computer. You can make a spreadsheet on your calculator, kind of. All right? And I'll show you that tomorrow. I'm not ready for lunch yet, but soon.